these acronyms mean something to you? RoCE, 32 gig FC, NVMe, TCP/IP. They should, because I/O matters. Hi, this is Todd Owens. I'm the Technical Field Marketing Manager at Marvell on the HPE team. Marvell is a strategic supplier of products and technology to HPE that are used in HPE servers, storage, and networking products. And today I want to talk about a technology that a lot of people in the storage business are talking about, and it's NVMe over fabrics. So let's start by looking at our data center environment again. So we've got a data center with multiple servers connected over a network, and there's some kind of an I/O device in each of those servers. Now they connect down to a storage array. Now in this case, I'm going to make the storage array kind of big because we're going to talk a little bit about what goes on inside the storage array. So in the storage array, there's a target adapter, and usually there's some kind of an ASIC. I'm going to just put a T for a target adapter. And there's some kind of an ASIC, or the brains or CPU, that's in that storage device that's doing a lot of the processing of the storage data. And then sitting in that storage device is usually some form of disks, a bunch of disks that go into your array. These disks in the old days used to be connected by SAS or SATA through some kind of a controller to that ASIC. But in the newer technology, what we're starting to see is a little network in here. And this network is using RDMA enabled networking that runs NVMe over an RDMA fabric. So NVMe over fabric. So inside the newer technology arrays, what you're going to see is a SATA and SAS disk replaced by a low-cost, low-latency network inside the disk array itself connected to the ASIC. The challenge is you're still talking Fibre Channel or iSCSI for the most part to the network. But over time, that's going to change, right? So we've got NVMe, that's our disk, and it could be our disk up in our servers as well. But eventually, we need that NVMe to be coming out of the array. We need native NVMe connectivity up to our I/O devices. So all of these devices need to be NVMe ready, right? They need to be NVMe enabled. It's not here today, but it's coming. The picture I've drawn here is essentially an HPE Primera. Today, Primera uses Fibre Channel connectivity to the network through the target adapter. Over time, that Fibre Channel is going to get replaced with NVMe. So let's talk about the different type of fabrics that we can have here. So NVMe, we call it NVMe over fabrics. So the first thing, and the one that will probably be the most common, is FC NVMe. NVMe, there we go. Why do I say it'll be the most common? Because most storage arrays today are connected on a Fibre Channel SAN. And the good news for HPE customers out there, HPE has been future-proofing customers with 16 gigabit and 32 gigabit Fibre Channel infrastructure that's already NVMe enabled. The Fibre Channel adapters up here in the servers, the switches down here in the fabric are all NVMe ready today. So any customers deployed HPE 16 or 32 gig adapters already can connect to an NVMe array in the very near future. So this is essentially no real change for the customer. They've already got the infrastructure. One thing to be aware of is looking for adapters that can run FC NVMe and the traditional FCP protocols concurrently, because what that enables you to do is not have to rip and replace your environment. So I can take another disk array that's sitting out here, that's my legacy disk array that's running Fibre Channel, and I can add in a new NVMe array and still run my Fibre Channel array because I can concurrently run FCP and NVMe on the same system. I don't have to add new adapters up in the server. So that's something to be cognizant of. The other way that we can get NVMe over a fabric is with using Ethernet, okay? So if we use Ethernet, we have two ways of doing this. Well, two ways that people talk about today. One is NVMe over RoCE, RDMA, and the other one is NVMe over iWarp, RDMA. Now, the reason they talk about RDMA is you're using NVMe, which is a lower latency, higher performance disk, so obviously you want to use a low latency network. Well, that's great, except it adds complexity. If this becomes an Ethernet network, and I'm using RoCE now, it needs to be a converged Ethernet. So I have limitations there. If I run iWarp, I've got to make sure that the target adapter supports iWarp. And right now, if you look at the roadmap of most storage array vendors, there's not a whole lot that are going to have iWarp Ethernet connectivity. They're going to use RoCE because RoCE's been around for about 10 or 11 years. It's considered to be more proven than iWarp from a storage perspective. And we all know that storage people are very conservative when it comes to deploying technology. There's a new kid on the block. As of November of 2018, there was a new NVMe spec that was ratified, and that's NVMe over TCP, okay? This is no low latency, just standard TCP IP. The advantage here is, think about the customer who has the installed base of servers today. They have a bunch of 10 gig adapters in those servers, a bunch of blinky lights in the data center, as we say. How many of those adapters are RDMA enabled? Very few, less than 5% today. If you look at the deployment of 10 gig Ethernet. That means 95% of the servers in the data center, if you want to connect to one of these new systems, you're going to have to change the adapter in the server. That's not a very likely scenario for most customers. So in a greenfield environment, sure, we can use FC and NVMe. If we've already got a SAN, we can use RoCE or iWarp. Probably RoCE, again, because that's what the storage guys are going to come out with. But for most customers, TCP is good enough. Now, the way I equate this, if we take iWarp out of the equation, assuming there's going to be no arrays that support iWarp today, okay, we end up with three different approaches: Fibre Channel, RoCE, and TCP. Let's look at where we are today. When we connect storage devices to a network today, how do we do that? We have three choices: Fibre Channel, FCOE, and iSCSI. Well, Fibre Channel, FCOE, and iSCSI, right? When performance is not the most important, but connectivity is, simplicity is, this TCP is going to work really well. If you've already got Fibre Channel, you're going to stay on Fibre Channel. Right, this NVMe over this fabric with RDMA is absolutely technically possible, but likely only for the early adopters. My bet is 2-3 years from now, we're going to see a lot of people deploying FC NVMe, and we're going to be seeing a lot of people deploying NVMe over TCP. And this is the Fibre Channel and the iSCSI world that we're going to live in, 3, 4, 5 years from now. This isn't here today. It's coming. But what you want to do is make sure you use Hewlett-Packard Enterprise I/O devices that allow you to future-proof the servers that you're deploying today for the NVMe arrays that are coming tomorrow. And that means 10 or 25 gigabit Ethernet adapters that support RDMA and Fibre Channel adapters that are 16 or 32 gig and that support NVMe over Fibre Channel transfers. Thanks for watching. This is Todd Owens. My contact details are below here. Feel free to reach out to me at any time with any questions that you might have relating to I/O technology.